All right. So, problem 2.26. What number should replace the question mark in each of the following? A, 1 centimeter is how many meters? All right. So, to solve this problem, we want to know how many meters. We put an equal sign. We draw our train tracks. Meters. Meters has to be on top. Centimeters has to be on the bottom. We start with 1 centimeter. For every 1 meter, there's 100 centimeters. So we take 1 divided by 100. That's 0.01 meters. All right. B. 1 kilometer is how many meters? 1 kilometer, how many meters? Equal sign, how many meters? Our train track, meters have to be on the top, kilometers are going to be on the bottom. We have 1 kilometer, and in every 1 kilometer, there's 1,000 meters. So, how many meters are there in 1 kilometer? 1,000 meters. All right, C, 1 meter and 1 peak, or how many picometers? 1 meter equals how many picometers? All right, so we have our equal sign. We want to know how many meters. Oh, thank you, sir. Thank you, Bobby Joby. Got it. Sorry, how many picometers in 1 meter? Well, we're going to need meters on the bottom. Picometers on the top. All right. Milli, it's 1,000 millimeters in a meter. Micro, 1,000,000 micrometers in a meter. Nano, 1,000,000,000 nanometers. And then pico, 1,000,000,000,000 picometers. So that's 1 times 10 to the 9th is nano, and then 12th is pico. That many picometers in 1 meter. So the answer is going to be 1 times 10 to the 12th. Picometers. Again, 1 times 10 to the 3rd, that's millimeter. 1 times 10 to the 6th, micrometers. 1 times 10 to the 9th, nanometers for every meter. And 1 times 10 to the 12th, picometers for every meter. Okay, 1 D says dm, that's decimeter. 1 decimeter, how many meters is that? Correct, we would like to know how many meters. Put an equal sign and a train track. Meters has to be on the top because we want meters at the end. Decimeters, it goes on the bottom. If we have 1 decimeter, we know that 1 meter contains 10 decimeters. There are 10 decimeters in 1 meter. Therefore, 1 meter, or 1 decimeter is 0.1 meter, or 1 divided by 10. E, 1 gram equals how many kilograms? 1 gram equals how many kilograms? We want to know how many kilograms. Train tracks. We start with 1 gram. We need grams on the bottom, kilograms on top. 1 gram, how many grams are in a kilogram? There's 1,000 grams for every 1 kilogram. So 1 divided by 1,000, and that's how many kilograms there are in 1 gram, or 0.001 kilograms. All right. F, centigram in 1 gram. If I have 1 centigram, how many grams is that? We would like to know how many grams are in 1 centigram. Well, a centigram is cent, like century, 1/100. So sorry, there's 100 centigrams for every gram. So 1 divided by 100, 0.01 grams for every 1 centigram is equal to 1 centigram. All right, that's problem 226. problem 228. Okay? Perform the following conversions: 57 degrees Celsius to degrees Fahrenheit. All right? So, this is a plug-and-chug problem. We have an equation, temperature in Fahrenheit equals 9/5 times temperature in Celsius. Whoops, that's a C. Temperature in Celsius plus 32. All right? So we have the temperature in Fahrenheit, 57 degrees Celsius, and we're converting that to Fahrenheit. We have our equation. This is the equation on page 57. This is just a plug-and-chug problem. In other words, you have this equation and you have this one, either degrees Fahrenheit or degrees Celsius, and you just plug and get the answer. Now, I'm not going to require you to memorize this equation, degrees Celsius to degrees Fahrenheit equation. Okay? So we have to put in 57 into this degrees Celsius here. 57. So first, order of operations, right? We have to multiply 57 times 9/5, and then we add 32. So we take 57 times 9 divided by 5, and then we add 32. All right, so that's 134.6. So a temperature in Fahrenheit is 134.6 degrees Fahrenheit. This is B, 16 degrees Celsius to degrees Fahrenheit. Again, 16 times 9 divided by 5 plus 32. Put that in our calculator that way. 16 times 9 divided by 5 plus 32. 60.8 degrees. 8 degrees Fahrenheit. All right, that's B. C, 25.5 degrees Fahrenheit. .5 degrees Fahrenheit is how many degrees Celsius? All right, so we're now given this value right here, 25.5. We have to subtract 32 first. Again, our order of operations, and that's going to equal 9/5 times the temperature in Celsius. So we have 25.5 25.5 minus 32 times 5 divided by 9. Alright, so 25.5 degrees Fahrenheit is a minus 3.6 degrees, minus 3.6 degrees Celsius. Minus 3.6 degrees Celsius. Alright, that was letter C on 228. C, 49 degrees Fahrenheit. Letter D, 49 degrees Fahrenheit to Celsius. 49 degrees Fahrenheit to degrees Celsius. Alright, 49 goes here. 49 minus 32 equals 9/5 times the temperature at degrees Celsius. Okay, 49 minus 32 times 5 divided by 9, 9.4. So we have 49 degrees Fahrenheit is 9.4 degrees Celsius. Alright, the next one, 62 degrees Celsius is how much Kelvin? 62 degrees Celsius is how much Kelvin? 62 degrees Celsius is how much Kelvin, right? Well, we know that whatever the temperature in Celsius is, you add 273 to it to get the Kelvin. So if it's 62 degrees Celsius, you add 273, and this is something you need to memorize. 273 plus 62, and that will be 5, 12, 13, 335 degrees Kelvin. All right, or 335 Kelvin. So 62 degrees Celsius, add 273, and it's 335 Kelvin. All right, if I have negative 31 degrees Celsius, negative 31 degrees Celsius, then what is my degrees Kelvin? Well, I take negative 31 and I add 273 and I get 242 Kelvin. 242 Kelvin. All right, and that's number 28. Number 30. A healthy dog has a temperature range of 37.2 degrees Celsius to 39.2 degrees Celsius. Is 103.5 within the normal range. All right? So the dog comes in, has a fever, and we want to know if it's dangerous or not. Okay? 37.2 degrees Celsius, and we want to know what the range is in Fahrenheit, right? Well, again, temperature in Fahrenheit is 9/5 the temperature in Celsius plus 32. Okay? And again, that equation is on page 57. All right. So we take our temperature in Celsius. Here we are, 37.2. 37.2 plus, well, first we have to multiply by 9, divide by 5, and then we add 32, and that'll give us our temperature in Fahrenheit. Okay? So we take 37.2 times 9 divided by 5, and then add 32 to it. That's 98.96. So that's 37.2. 98.96. Then we take 39.2 and do the same thing. 39.2 times 9 divided by 5, add 32. 71.2. Oh, what did we do wrong there? Let's try that again. 39.2. 39.2 times 9 equals, divided by 5 equals, plus 32. There we go, 102.56. 102.56 degrees Fahrenheit. So that's the range that a normal dog is, right? And the question is 103.5, is that within the normal range? And the answer is no. Oops, that was number 230. Number 230. And the answer is no. 232. Estimate the temperature of the core of the sun. Estimates of the temperature of the core of the sun range from 10 megakelvins to 25 megakelvins. What is this temperature in range in Celsius and degrees Fahrenheit? Alright, so we're on number 232 now. And we're told that it's 10 megakelvins to 25 megakelvins. 10 mega, 1, 2, 3, 1, 2, 3. That's 10 megakelvins to 25 megakelvins. 25, 1, 2, 3, 1, 2, 3 kelvins, right? So, to convert this to degrees Celsius, right? If we have degrees Celsius, we add 273 to get Kelvin. If we have Kelvin, we subtract 273. So 10 million and 25 million minus 273 is, I mean, we can take 10 million 9999727. And then 24,999,727. Oops. Right? Just double check. 25. $24,999,727. All right, so that's the range in degrees Celsius. And the range in Fahrenheit. Again, our equation, temperature in Fahrenheit is 9/5 temperature in degrees Celsius plus 32, right? So whatever the temperature is here, temperature degrees Celsius, times 9 divided by 5 equals, and then we add 32 equals, so we're looking at 45 million here, approximately, degrees Fahrenheit, 9999727 times 9 divided by 5 plus 32, we're looking at 18 million. Approximately 18 million degrees Fahrenheit. So about 18 million degrees Fahrenheit to 45 million degrees Fahrenheit. Okay. Helium has the lowest boiling point, so now we're on 234. Helium has the lowest boiling point of any liquid. It boils at 4 Kelvin. What's the boiling point in degrees Celsius? 4 Kelvin. What's the boiling point in degrees Celsius? So again, if we have degrees Celsius and we want to go to Kelvin, we add 273. If we have 4 and if we have Kelvin and we want to go to degrees Celsius, we subtract 273. Well, therefore, at 0 Kelvin, degrees Celsius is minus 273, right? So we're looking at 277 here, right? So 4 minus 270. So we go from here to there, we subtract 273. So 4 minus 273, which is the same as minus 273 plus 4. So it's minus 269, right? Kelvin is going to be a minus 269. Okay. Now we're on problem 230. That was 234. 236 now. 236. How many significant figures do the following measured quantities have? 37.53. 37.53. Any number, if it's a number other than 0, is a significant digit. And all 4 of those are numbers other than 0, so that answer is 4. There's 4 significant digits. Alright? So that's A, 236A. 236B, 37.240. 37.240. B, this is in, or it says centimeters, but that doesn't alter how many significant figures there are. Numbers are all significant digits, numbers that aren't zeros, 1, 2, 3, 4, and zeros at the end are significant as well. So after the decimal point, at the end. If it's after the decimal point and at the end, then it is significant. So that's 1, 2, 3, 4, 5. All right? If you're confused about significant digits, you can go back and read that section in the book to try to further understand what's going on. But we have 4 significant digits that are because they're numbers other than 0, and then we have 0 after the decimal point. So, and after number values, so this is 5 significant digits. All right? So 236B, it's 5. This is a 5. sig figs. Significant figures. All right, 202.0. 202.0. All right. 1, 2, 3. Any zeros that are surrounded by non-zero numbers are significant. So that's 3 significant digits there. And this is a 0 beyond the decimal point. So that's 4 significant figures. Okay? So that's 236C, 4 significant figures. 236D, 0.00024. All right, here we have 2 significant digits. Those 2 right there, non-zeros, are always significant. These zeros right here are just placeholders. They're just there. We could easily change this number. So the units on this are kilograms, and we could just move this decimal place over and make it 0.24, 0.24 grams. Now, where would those zeros go? Would we minimize the number of significant figures just because we said it was in grams instead of kilograms? No. Therefore, that's evidence that those zeros are not significant values. Okay? So the answer is 2 significant digits for letter D, 236D. 236C, 0.078. 0.07080. Alright? Here we have how many significant digits? Well, definitely this one, and the 0 surrounded by them. So non-zero digits and anything that's in the middle are significant digits. So that's 1, 2, 3. And then this one is also significant because it's a 0 beyond the decimal point and behind a non-zero digit. Alright, so we have 4 significant digits there. 4 significant digits. This 0, again, is not significant. It's just a placeholder. Alright, that's E with 4 significant digits. F, 2400. 2400, 1, 2 significant digits. These zeros, there's no indication that they're significant. Therefore, this answer just has 2 significant figures. If we were to add a decimal place there, that would make it 4 significant digits. That means that there was a way to measure those zeros, and we know there's zeros. But without that, we don't know, and we have to assume that it's just 2 significant figures. Sometimes in these problems, they'll tell us that this actually is 4 significant digits, but based on, unless they tell us otherwise, we only can assume 2 of those are significant. Alright, so that was 236. We're on to 238. 238, doing arithmetic with digits and trying to determine the resulting significant figures. Perform the following arithmetic and round off the answers to the correct number of significant figures. Include the correct units with the answer. 0.0023. 0.0023 meters times 0.31 or times 315 meters. All right, 0.0023 times 315. 0.0023 times 315. 0.7245 or 0.7245. Now this figure here has 3 significant digits. This figure here has 2 significant digits. Okay? So because this only has 2 significant digits, our answer can only have 2 significant digits. So we have to round to this second significant digit. That 2 doesn't round up, so it's just 72.72. The units, this was meters and that was meters. So we multiply meters by each other, and that's meters squared. So it's 0.72 meters squared. 2 significant digits. And that's because when you're multiplying 2 values together or dividing 2 values from each other, in between each other, the one with the fewest significant figures limits the answer's significant figures. Alright, 238b. 84.25 minus 0.01075. Alright, so that's 84.25. 84.25 minus 0.01075. 0.01075. Okay, so this is kilograms minus kilograms, right? So the answer, the units, first of all, are in kilograms. We can do this on our calculator. 84.25 minus 0.01075. Alright, so the answer is 84.23925. 84.23925. Now, when we're doing addition problems, we don't determine the number of significant figures. We just look, addition or subtraction, we just look and see which number has the fewest number of significant digits beyond the decimal place, or the fewest numbers beyond the decimal place. And that's where our answer has to be limited to. So this is going to, answer is going to be 84.2, and this 3 is rounded using the neighboring number, so it rounds up to a 4 in this case. So 84.24, kilograms minus kilograms leaves you with kilograms. Alright. That's 238B. 238C. 238C. 184.45. 184.45 minus 94.45. Minus 94.45. And these units are in grams. That's in parentheses. And that's divided by 31.4 divided by 31.4 milliliters minus 9.9 milliliters. Okay? Order of operations, we do what's inside the parentheses first. 184.45 minus 94.45. I like to line these up so that we can see how many significant digits we should be limited to. 184.45, 184.45 minus 94.45. The answer is 90.00. Alright? And we see that both of these are limited to 2 significant digits beyond the decimal point. So that means our answer has 4 significant digits here. Again, when we're doing addition or subtraction, and this is a subtraction problem here, we just look at the one that has the fewest number of significant digits beyond the decimal point. And both of these have 2. So that means we include 2 significant digits to the right of the decimal point. And however many digits are on the left, that just determines on how the problem turns out. Okay? Okay, so now, this other side, 31.4 minus 9.9. Again, we see we have 1. Alright, so let's finish up this problem here. Alright, so we finish up 2.38. Finish up 2.38. We see that we took 313.44 minus 209.1. The answer was 104.34, but we were limited to only 1 digit beyond the decimal point. So it's 104.3. We carry that 104.3, multiply it by 8.2234. The answer is 857.70062. But we round that to 4 significant digits because this one has only 4 significant digits. So the answer is 857.7. And the units here were centimeters and there are centimeters. So this difference is centimeters. This is centimeters over here. Centimeters times centimeters is centimeters squared. Alright? Alright, that's 238. Okay, now we go on to 240. Perform the following conversions. Perform the following conversions. 32.0 decimeters per second to kilometers per hour. We want kilometers per hour. We have decimeters per second. We put our equal sign, we draw our train tracks. Alright? Okay, so let's make sure we got this written right. 32 decimeters per second to kilometers per hour. Again, we write our equal sign, we write our train tracks. I don't know how many conversions we're going to need, but we have kilometers to hours. Seconds. So we're going to do this once. seconds, if we want to convert seconds to hours, well, we don't need to do that. Alright, if we want to go seconds to hours, we need hours on the bottom and seconds on top. How many seconds are there for every hour? For every 1 hour, there's 60 minutes, and for every minute, there's 60 seconds. So there's 60 times 60, which is 3,600 seconds for every hour. Okay? 1 hour has 3,600 seconds. So now this will cross out seconds and leave us with hours on the bottom. Decimeters. The units were 1 decimeter per second, and we want to know how many kilometers per hour that is. Oh no, 32 decimeters per second. Sorry. 32. 32.0 decimeters per second. Okay? Well, for every 1 decimeter, or sorry, for every 10 decimeters, there's 1 meter, right? And for every 1 meter, there's, no, sorry, for every 1,000 meters, there's 1 kilometer. Alright, so hope you can see that. 32 decimeters per second. For every 1 meter, there's 10 decimeters. For every 1 kilometer, there's 1,000 meters. This gets the decimeters to cancel out. It gets the meters to cancel out. And we're left with kilometers. Our seconds were canceled out there per hour. And that's what we want, kilometers per hour. So we put this into our calculator. We put 32 divided by 10 divided by 1,000 times 3,600. Alright, so we have 32 divided by 10 divided by 1,000 times 3,600. .52. So that's 11.52 kilometers per hour. Alright, so that's 240A. Next one. 240B, 8.2 milligrams per milliliter. And we want to convert that into micrograms per liter. Micrograms per liter. Right? So we put micrograms per liter. This is the units we want. We put an equal sign. We extend out these train tracks. Okay? Milligrams on top and milliliters on the bottom. We can get milliliters to liters for every, we put milliliter, we have milliliters on the bottom and we want liters on the bottom. So we put liters on the bottom, put milliliters here. For every 1,000 milliliters, there's 1 liter, right? Milligrams, 8.2, is that right? 8.2 milligrams. So how many micrograms is that? Well, there are 1,000 micrograms for every milligram, right? So we have milligrams on the bottom, so that'll cancel out the milligrams here. And we have micrograms here. So there are 1,000 micrograms for every 1 milligram. So 8.2 times 1,000 times 1,000, and that'll tell us how many micrograms per liter. Alright, so 8.2 times 10 to the 6th. Micrograms per liter. Okay, so we have that many milligrams for every milliliter. It would be 1,000 times more, or 8.2 times 10 to the third, micrograms per milliliter, and then 1,000 more to go to micrograms per liter. Alright, 240, that was 240B. 240C, 75.3 milligrams to kilograms. 75.3 milligrams to kilograms. Well, how many grams are there per milligram, right? There's 1,000 milligrams for every 1 gram, and for every kilogram, there's 1,000 grams. All right? We put milligrams on the bottom. That cancels milligrams out there. and we're in grams. We put grams on the bottom over here. That cancels out grams, and so we're left in kilograms. So if we had 75.3 milligrams, we take that value, divide it by 1,000, divide it by 1,000 again. So that's going to be 75.3 times 10 to the minus 6 kilograms. This isn't quite scientific notation because this is not in between 1 and 10. It's 75.3. So we can go 7.53 times 10 to the minus 5 kilograms, right? All right, so 7.53 times 10 to the minus 5 kilograms. Okay, D, 137.5 milliliters to liters. 137.5 milliliters to liters. Now this is one you want to learn how to do in your head. Milliliters to liters and liters to milliliters. 137.5 milliliters to liters. Okay? You want to learn how to do this in your head eventually, but if you don't know right now, that's all right. We have, just to verify here, 137.5 milliliters to liters. We want to get rid of milliliters and we want liters to be on top, right? So we have to have liters on the bottom, on top, milliliters on the bottom, and then we put in our values. There's 1,000 milliliters for every liter. So 137.5 divided by 1,000, which is 0.1375 liters. All right. 0.025 liters is how many milliliters? 0.025 liters, train tracks, equals how many milliliters, right? So we want liters on the bottom to cancel that out. We want milliliters on the top there. There are 1,000 milliliters for every liter. Therefore, if we multiply this value by 1,000, that's going to be 25 milliliters in 0.025 liters. All right, 342 picometers squared to how many decimeters squared? 342 picometers squared. 342 picometers squared. And how many decimeters squared is that? All right. When we say 342 picometers squared, that's an area, 342 picometers squared, right? So we have a box. We'll draw it like this. It has an area of 342 picometers squared. So what are the units on the side there? It's the square root of 342, right? Because that's something times something equaled 342. So that's 18.49. 18.49. 18.49, right? And those are picometers. Picometers. If we want to convert this picometers to decimeters now, all right? Can convert this picometers to decimeters. 18.49 picometers. How many decimeters are in a picometer, right? Well, we can convert this picometers to meters first. So if we have 18.49 picometers and we want to convert it to meters, for every 1 meter, there's 1 times 10 to the 12th picometers. All right? So if we have 18.49 picometers, how many meters is that? It's 18.49 divided by 1 times 10 to the 12th. All right? And that would be how many meters. If we wanted to take that into decimeters, let's try this again over here. 18.49 picometers. We're eventually going to get to decimeters here, right? Picometers to meters, 1 times 10 to the minus 12 picometers for every 1 meter, right? And then we have 10 decimeters for every 1 meter. So instead of 1 times 10 to the minus 12, it's just going to be 1 times 10 to the minus 11, or 1 times 10 to the minus 12 times 10. Okay, so we've got 18.49 divided by 1 times 10 to the minus 12 times 10. Okay? Oh, I need to go get a better calculator. So 18.49 picometers is 1.849 times 10 to the minus 10 decimeters. Alright? So now we take that 1.849 times 10 to the minus 10 decimeters and we multiply it by itself, or we square it, in other words, and that should be the area of 342 picometers. And I'm getting 3.418, or 3.42 times 10 to the minus 20. .42 times 10 to the minus 20. Alright, I'm going to check that one, make sure we did it right. Alright, so we got it. 3.42 times 10 to the minus 20 decimeters. Alright. Okay, so now we're on to 242. 242. Perform the following conversions. If necessary, refer to tables 2.3 and 2.4. 37 inches to centimeters. 37 inches to centimeters. 37 inches, and we want to convert that to centimeters. Alright? So we write what we would like the units to be. We write the value that we start with, and then we try to convert it. Alright? Inches. Well, there's one conversion that I would like you to remember. It helps you to do meters to feet and inches to meters and centimeters. Alright? It is 2.54 centimeters for every inch. So if we have inches on the bottom here and we need centimeters on the top, 2.54 centimeters for every 1 inch. Alright? Now that'll cross out inches on the top here and leave us with centimeters on the top. So 37 inches is how many centimeters? Well, it's 37 times 2.54, right? 37 times 2.54, and that's 93.98. 93.98. We only have 2 significant digits, so it's going to be 94 centimeters probably. Okay, that is the first one, 36 inches to centimeters. 5 pounds to kilograms. 5 pounds. And we would like to know how many kilograms. Alright? And they say we can refer to 234, or 2.3 and 2.4. tables 2.3 and 2.4, to find out how many kilograms are in how many pounds. So says 1 pound is 453.6 grams. So we have 1 pound, 453.6 grams. All right, 1 pound is 453.6 grams. So we can go from pounds to grams with that conversion factor, and we can go from grams to kilograms, knowing that there's 1,000 grams for every kilogram. So we take 55 pounds, 5, multiplied by 453.6, divided by 1,000. Because there's 1,000 grams for every kilogram. And that's 2.268 kilograms. All right? Okay, and the next one, 3 quarts, 2 milliliters. 3 quarts, and we want to go to milliliters, right? All right, so that's a volume. Quarts, there's 946.4 milliliters per quart. So we have 1 quart. We put that down here again because we want it to cancel out there. 346.9. Oh, let's see. 946.4, sorry. 946.4 milliliters. Alright, so we're already in milliliters. Quarts cancel out. 3 times 946.4 equals, and we got 2839.2. 2839.2 milliliters. Alright. 2.42, 1 cup, or 8 ounces, and we want to convert that to milliliters, all right? So if we have 8 ounces, how many milliliters? Well, there's 29.6 milliliters per ounce. So 1 cup, which is 8 ounces, and we want to know how many milliliters that is. And we're told that there's 29.6 milliliters per ounce. So for every 1 ounce, there's 29.6 milliliters. Now, I'm not going to expect you to memorize these ounces to milliliters, quarts to milliliters, gallons to liters, ounces to grams, miles to kilometers, and all that. The one that I want you to memorize, because it will help you significantly in a lot of different ways, is 2.54 centimeters for every inch. Okay? If you just remember that one, that'll get you a lot of the way for a lot of the problems. Okay? So again, 8 ounces, and every ounce is 29.6 milliliters. Alright, so we have 8 times 29.6. 236.8 milliliters. 236.8 milliliters. So that's how many milliliters there are in 8 ounces. Okay? So 2.42 E, 55 miles per hour. How many kilometers per hour is that? 55 miles per hour. How many kilometers per hour? So we have 55 miles per hour. And how many kilometers per hour is that? Again, we write what we want, the units for what we want, kilometers per hour, the units for what we have, miles per hour, and we convert miles here to kilometers. So we need miles on the bottom. If we know how many kilometers there are in a mile, 1 mile is 1.609 kilometers. 1 mile, 1.609 kilometers. Alright, so 55 times 1.609. So that's 88.495 kilometers. And hours are the same here and here, so we don't have to do anything there. So the answer is 88.495 kilometers per hour. We started off with 2 significant figures, so this answer is only going to have 2 significant figures, 88 kilometers per hour. Okay? Alright. Now we're on to 244. Number 244. Perform the following conversions: 8.42 feet squared to centimeters squared. 8.42, again, that's feet squared to centimeters squared. Feet squared, and we want to go to centimeters squared. Alright? Well, the most logical way for me to approach these types of problems is, again, to draw myself a square. Say this is 8.42 feet squared, and I try to find the length of that distance right there, or the length of that distance, right? Which is the square root of 8.42. So that's 2.90, and that's in feet. Now I can convert that feet to centimeters. First I can convert it to inches, multiplying it by 12. 2.90 feet is the same as 34.8 inches. And there's 2.54 centimeters per inch, so I multiply that by 2.54, and that's 88.44. So this length here is also equivalent to 88.44 centimeters. Alright, now I have that distance in centimeters, so if I square that value, that'll be the area of this in centimeters squared. So I square 88.44, and I get 7,822. That's equal to 7,822 centimeters squared. We have 3 significant digits, so it's going to be 7,820 centimeters squared. Alright, because that's 3. 1, 2, 3 significant digits. Again, that 0 is not significant, right? Alright, so that is the answer to 2.44a. 2.44b says 223 miles squared is how many kilometers squared? 223 miles squared is how many kilometers squared, right? I have an area of land, it's 223 miles squared. This length then is the square root of 223, which is 14.93 miles. If I want to convert 14.93 miles to kilometers, 1 mile is 1.609 kilometers. 1 mile, and I want to convert it to kilometers. For every 1 mile, 1.69, what did I say? 609. 1.609 kilometers. So if I multiply 14.93 times my 1.609 kilometers, alright, miles will cancel out, I'll be left with kilometers on top. So I multiply the 14.93 times 1.609, and that's 24.027 kilometers. So this distance is 14.93 miles, which is equivalent to what we just found, 24.027 kilometers. Now I just have to square that value, and that means that this is equivalent to 577.3 kilometers squared. Alright, that's 244B, 244C. 231 feet cubed is how many centimeters cubed? .231 feet cubed is how many centimeters cubed? 231 feet cubed. 231 feet cubed is how many centimeters cubed? Okay? So, same thing. This time I have a cube. A cube which has a volume of 231 feet cubed. Therefore, thank you, Sister Scott. It's outstanding. She's outstanding. 231 feet cubed. So if I take the cube root of 231, and you can take the cube root, you can figure out how to do it on your calculator. The easiest way for me is always to raise it to the power of 1 over 3. That seems to be always easy to remember. So if I take 231, type in 231, raise it to the parentheses 1 over 3 end parentheses, and that'll be the cube root, which is 6.135. So that means the distance of this side is 6.135. Distance of that, one of the sides of the cubes, or all of the sides of the cubes, right? Now if I convert that 6.135, it's in feet, convert it to centimeters. There's 1 foot, 12 inches. 1 inch, 2.54 centimeters. And that'll tell us how many centimeters there are. 6.135, what we just had on our calculator, times 12, converting it to inches, times 2.54, converting it to centimeters. That means 231, that means 6.135 feet is 187 centimeters. Thank you. Okay, so 6.35 feet is equivalent to 187 centimeters we found. Now we know that the length of this side, or length of all of these sides, is 187 centimeters. So if we raise that value to the third power, that will tell us how many cubic centimeters are in 231 cubic feet. And I'm getting a value of 6,541,000. So we have 6,540,000. All right. And that seems like a lot, so let's double check that in the back. Uh, 244. 244. And that's right, 6.54 times 10 to the 6th. Alright, you got it. That was 244C. 246. .246. The human stomach can expand to hold up to 4.2 quarts of food. A pistachio nut has a volume of about 0.9 milliliters. Use this information to estimate the maximum number of pistachios that you can eat in one sitting. Sister Scott loves pistachios. Huh?
Yes.
Alright. Holds up to 4.2 quarts of food. So 4.2 quarts. Pistachio has a volume of 0.9 milliliters. Use this information to estimate the number of pistachios that can be eaten in one setting. So basically, we want to take 4.2 quarts and divide it by 0.9 milliliters. But we want them to be in the same units. So first, let's we could convert the quarts to milliliters or the milliliters to quarts. And I think I will convert our 4.2 quarts to milliliters. So if we have 4.2 quarts equals sign, and we want to know how many milliliters. This is what we have. That's what we want to know, right? Because if we know how many milliliters the stomach is, then we can convert that into, or we can divide that by the milliliters of a pistachio nut. So volume, table 2.3, quarts, 1 quart, 946.4 milliliters. 1 quart, 946.4 milliliters. All right, so 4.2 quarts, the size of our stomach. So we have 4.2 times 946.4. Again, we put milliliters on top, quarts on bottoms, quarts cancel out. 4.2 times 946.4 milliliters equals 4.2 times 946.4 equals 3,974.88 milliliters. 3,974.88 milliliters. We can divide that by, and again, this is only 2 significant digits, so if we wanted to do it correctly, this 39 would have to be rounded up to 4,000 milliliters with 2 significant digits. All right. We don't have to stop right there, though. We can just divide that by the volume of a pistachio nut, which is 0.9 milliliters. So if we divide that by 0.9 milliliters, divide that by 0.9, then the answer is 4,416 pistachio nuts. All right, so this is the volume of the pistachio per pistachio here, and this is the volume in your stomach, that many milliliters per stomach. All right, and that'll mean we'll be able to get that many pistachios for that much stomach. All right, or for every stomach, that's how many pistachios, and the number is 4,416, which is going to round using 1 decimal place. So the answer should be in the back of the book as 4,000. $2.46, 4,000 pistachios. Then we get a nice friendly hint, or a nice friendly advice. Don't try this at home. Yeah. All right. 248. The wind in a hurricane can reach about 200 miles per hour. What is this speed in meters per second? And then it says assume that all 3 digits are significant. 248. Okay? MI, miles per hour. 200 miles per hour. We have an equal sign, and we want to know, was it meters per second? Meters per second. This is what we want to know. Meters per second. Miles per hour, we have to go to meters per second. Hour. We know how to deal with this. We did this before. Hours on top. Seconds on the bottom. For every 1 hour, there's 3,600 seconds, right? Because 1 hour contains 60 minutes. So 1 times 60 determine how many minutes, times an additional 60 determines how many seconds, because there's 60 seconds for every minute. So we have 200 divided by 3,600, and that'll tell us how many miles per second, but we want meters per second. So now we have to go from miles to meters. And to go from miles to meters, we can use table 2.3. Length, 1 mile is, it doesn't tell us how many meters it is, but it tells us how many kilometers, which is 1.609. So we can give ourselves a little extra room here. 1.609 kilometers for every 1 meter or mile. Miles go on bottom again because miles are here and we're trying to get rid of miles. We're in kilometers now, and kilometers go on bottom. Finally, meters on top. 1,000 meters for every 1 kilometer. So we have 200 divided by 3,600 times 1.609 and times 1,000. 200 divided by 3,600 times 1.609 times 1,000. So I got 89.4 meters per second. 89.4 meters per second. Alright, 200 miles per hour, 89.4 meters per second. That was 248. 250, a bullet leaving a muzzle of a pistol. .250, a bullet leaving the muzzle of a pistol traveling at a speed of 2,230 feet per second. 2,230 feet for every 1 second. What's the speed in miles per hour? Feet per second, equal sign. We're looking for miles per hour. Alright, 2,230 feet per second. Well, how many feet are there for every 1 mile? Okay, so we have 2,230 feet per second, and we want to go to every mile per second by converting the feet into miles. And there are 5,280 feet in 1 mile. So 5,280 feet, and I had to look that up on the internet. That's alright, these aren't numbers that I think are worth memorizing. That's how many feet there are per mile, right? I mean, you'll memorize it if we use it plenty of times, and every year we re-memorize it and then it goes away. So 5,280 feet per mile. So this is how many feet there are per second. This is how many miles there are per feet. Feet cancel out. We're now in miles per second, and we want to go to miles per hour. So we have seconds on the bottom, and we want hours on the bottom. So we put seconds up here. And again, there's 3,600 seconds for every hour. So we have 2,230 times, or divided by 5,280 times 3,600. So that's 1,520 miles per hour. Wow. Oh yeah, that was a bullet. Alright. 1,520 miles an hour. Okay, that was 250. Now we go on to 252. Alright, the brightest star in the night sky in the northern hemisphere is Sirius. Its distance from Earth is estimated to be 8.7 light years. A light year is the distance light travels in 1 year. Light travels at a speed of 3 times 10 to the 8th meters per second. Calculate the distance from Earth to Sirius in miles. And there they give us 1 mile is 5,280 feet. So they could have given us that for the previous problem. That would have been nice. So the question is the distance between of 8.7 light years in miles. So we're at 252, right? 8.7 light years is how many miles? So the unit we want it in is miles. The unit we have it in is 8.7 light years. I'll call that LY. 8.7 light years. A light year is distance traveled in 1 year. The light travels in 1 year. So the light travels at 3 times 10 to the 8th meters per second. Alright? So 3 times 10 to the 8th meters every second. So we have to determine how many seconds there are in a year. and then multiply that by 8.7. So a light year is distance traveled in light travels in 1 year. So let's see, 8.7 light years. That's 8.7. So let's determine what 1 light year is first. 1 light year is how much light travels in 1 year. And light travels at 3.00 times 10 to the 8th meters per second. 3.00 times 10 to the 8th meters for every 1 second. And we want to know a light year. That's basically how many we want to convert, or multiply this by how many seconds there are in a year. So we have to have a third one here for every year. Or if we have 1 year, start over here, 1 year, how many seconds are there? Alright, 1 year, there's 365 days. Is that close enough? How many days are there in a year, Mom? 365, but isn't it 365.25? Close enough. 365 days in a year. Oh, whoops. We need years on the bottom. For every 1 day, that's 24 hours. And for every 1 hour, that's 3,600 seconds. Alright, so that's how many seconds there are in a year. So, $365, solve this. How many 5 seconds? 365 times 1 divided by 1 times 24 times 3,600. So that's 3.15 times 10 to the 7? 3.15 times 10 to the 7. Alright, that's how many seconds there are for every year. So there's 3.15 times 10 to the 7th seconds in every 1 year. So that's how many meters it travels in 1 year, so therefore that's what a light year is. Alright? So down here we determined how many seconds there were in a year, and that's 3.15 times 10 to the 7th. And we multiply that many seconds times the speed of light to see how many meters it would go in 1 year. So if we take this value, 3.15 times 10 to the 7th, multiply it by times 3 times 10 to the 8th, that's how far light travels in 1 year. That's how many meters it travels in 1 year. Multiply that by 8.7 up here. That's how many light years it is away. And now we have 8.23 times 10 to the 16th meters. Alright? 8.23 times 10 to the 16th meters. That's how far away this star is. And what do we want to do? We want to convert that to calculate the distance from Earth in miles. Alright, so that's how many meters it is. Well, we know how many miles there are we know how many kilometers there are in a mile. 1.609 kilometers. So, if we want to get this in miles now, we have it in meters. There's 1,000 meters for 1 kilometer. 1.609 kilometers for every 1 mile. Right? So 8.23 times 10 to the 16th divided by 1,000 divided by 1.609. Divided by 1,000 divided by 1.609. And so we're looking at 5 times 10 to the 13th miles, or 5.1 times 10 to the 13th miles. Okay, so two significant figures up here, two significant figures
Number
down
254
here.
says the deepest point in the Earth's ocean is found in the Mariana Trench, a deep crevice located about 1,000 miles southeast of Japan, beneath the Pacific Ocean. Ooh. Its maximum depth is 6,033.5 fathoms. 1 fathom is defined as 6 feet. Calculate the depth of the Mariana Trench in meters.
We want it in meters, so we write the units we want, an equal sign, and a train track. And then up here in the top left, we write what we have. 6033.5 fathoms. 6033.5 fathoms. All right, 6,033.5 fathoms. All right, then we write the number of, we can convert fathoms to feet. 1 fathom, it says, is 6 feet. And then we can convert feet to meters, because that's what we want. And again, we use our table that is in table 2.3. Length. 1 yard is 0.9144 meters. 1 yard equals 0.9144 meters. Alright, so 6 feet, well, there's 3 feet in 1 yard. Right? And 1 yard is 0.9144 meters. Alright, so we started with fathoms. We got rid of fathoms and converted it to feet. We got rid of feet. Converted it to yards. We got rid of yards. And we're left with meters. Okay? So, calculate that out. Again, 6,033.5 times 6 divided by 3 times 0.9144. Alright, so it says 11,034. So we have an answer of 11,034 meters, and 1, 2, 3, 4, 5 significant digits is what we started with. So 11,034. Alright, very good. That's number 254. 256. A sample of kerosene weighs 36.4 grams. Its volume was measured to be 45.6 milliliters. What's the density of the kerosene in gram ml minus 1? So that means grams per milliliter, right? Grams ml minus 1. That ml to the minus 1 means it's moved down to the denominator. So that's the same as saying grams per milliliter, right? Okay, so it says that the grams is 36.4 grams, and the milliliters are 45.6, right? A sample of kerosene with a mass of 36.4 grams. Its volume was measured to be 45.6 milliliters. So 36.4 divided by 45.6 milliliters, and that is going to give us our density, because density equals mass over volume, and mass is in units of grams, volume can be in units of milliliters. So we have density 36.4 divided by 45.6. 0.798. And there are 3 significant figures.
0.798 units again are grams per milliliter. Alright, so that's the density in the problem of the kerosene. And that makes sense because oils are less dense than water, oils float on water, and the density of water is 1 gram for every milliliter.
Okay, so 256, next is 258.
Acetone, the solvent in some nail polish removers, has a density of 0.791 grams per milliliter.
0.791, and that's again grams per milliliter.
What is the volume in milliliters of 25 grams of acetone?
What's the volume in milliliters? We want to know milliliters. Put our equal sign, try a train tracks.
We're told how many grams we have. Again, 258. What's the volume in milliliters of 25.0 grams of acetone?
We have 25.0 grams, and we want to get to milliliters. So we need milliliters on top and something with grams on bottom. That can be the density, right? Because there's 0.791, 0.791 grams for every 1 milliliter, right? So then we take 25 divided by 0.791. Alright, so I have an answer, milliliters, 31.6 milliliters. 31.6 milliliters. Now, when you come across a problem like this where you're tempted to say, oh, 25 grams, 0.791, I need to divide them, right? Because the value, I know it's a density problem, blah, 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 I'm going to divide it. Well, you don't always treat the problem the exact same way. You have to set it up. You have to write what you need here, your train tracks and equal sign, and what you start with here. And then determine how it needs to be set up appropriately. People get into traps when they just assume how to solve a problem without writing it out and setting it up so they can visualize what's going on. Alright, so that's 258, 31.6 milliliters. 260. Chloroform.
Chloroform, a chemical once used as an anesthetic, has a density of 1.492 grams per milliliter.
1.492 grams per milliliter.
So we're given the density of chloroform. What is the mass in grams of 185 milliliters of chloroform?
Alright, so equal sign, we want mass in grams. We start with 185 milliliters. 185 milliliters, alright? So, how are we going to get grams on top if we have milliliters on top? Well, grams has to be on top, and milliliters has to be on bottom, so the milliliters will cancel out. So then we look up here the density, 1.492 grams for every milliliter. So that's 1.492, that's how many grams there are for every milliliter. So if we take 185 times 1.492, 276 grams. 276 grams. And that's problem 260. 262. We're on problem number 262. A graduated cylinder was filled with water to 15 milliliter mark and weighed on a balance. Its mass was 27.35 grams. An object made of silver was placed in the graduated cylinder and completely submerged in the water. The water level rose to 18.3 milliliters. When reweighed, the cylinder, water, and silver object had a total mass of 62 grams. Calculate the density in silver in grams per centimeter cubed, or the way they write it is gram centimeters to the minus 3. But that's the same as saying grams per centimeter cubed. Alright? Again, that centimeter to the minus 3 means we put the centimeters cubed in the denominator. Alright, so let's draw a picture of what's going on. We have a graduated cylinder. Right? A graduated cylinder means a cylinder that has marks on it to tell us how much volume of fluid we have. and we filled it up to 15 milliliters. So this is the 15 milliliter mark with water, right? So we have water up here to 15 milliliters. And then we take a piece of silver and we drop the piece of silver into the graduated cylinder. Well, first, before we do that, we take the mass of the whole thing, right? So we put this whole thing on a scale and we determine its mass. And it said its mass was, with the water and the graduated cylinder, 27.35 grams. Alright, so it was 27.35 grams with the water and the cylinder. Then we added the piece of silver. We added the piece of silver to the water and the cylinder, and the new mass was 62 grams. So we had a mass of 62.00 grams. Alright? So we took the 62 grams, or we took the silver, put it in, and the new mass was 62 grams. So we can find the mass of the silver, which would be just the 62 minus 27.35. So that's 34.65. 34.65 grams. Alright? So that's the mass of the piece of silver that we put in. Now, we want to find the density of the silver in grams per cubic centimeters. Now, a cubic centimeter, which means 1 by 1 by 1 by 1, right? So that's 1 centimeter by 1 centimeter by 1 centimeter. A cubic centimeter is equal to 1 milliliter. All right? Those two are equivalent. 1 milliliter is equal to 1 cubic centimeter. Different units of volume. So, we have the mass of the silver. Now we need to know the cubic centimeters of the silver, or the volume of the silver. And the way we can determine that is when we put the silver in, the water line rose to 18.3 milliliters. So if we take 18.3 and subtract 15.0, then we get 3.3. And we know that that is the volume, because this is in milliliters, right? This is milliliters and milliliters. So we know that that is the volume of this piece of silver. Because when silver or anything is submerged in water, then the amount of water it displaces will be its volume that it contains. If something floats on water, then it displaces the mass, the mass of itself. So, in whatever of whatever fluid that is. So, for example, you put a boat on the water, and it will push enough water out of the way that the amount of water weighs more than the boat, and so that makes the boat float. That's why you can make a boat out of steel. As long as the amount of water that the boat is displacing weighs more than the boat, then the boat will float. If you push a boat all the way underwater, and so it's submerged in the water, the amount of water that it's displacing is not equivalent to its mass anymore. It's now equivalent to its volume. So, in short, putting this piece of silver into the water, which makes sense, if it's submerged, the water will be displaced by its equivalent volume. So now we have our mass of the silver and our volume of the silver. That's 3.3 milliliters. That's the same as 3.3 cubic centimeters. So if we just take 34.65 divided by 3.3, we get 10.5. But there's only two significant figures, 3.3, two significant figures. So 10.5 has to be rounded up to 11, and that's grams per cubic centimeter. All right, that's 262. Last one, 264. All right, the space shuttle uses liquid hydrogen in its fuel. The external fuel tank used during takeoff carries 227,641 pounds of hydrogen. 227,641 pounds. Pounds of hydrogen. And that's hydrogen gas, H2, right?
with a volume of 385,265 gallons. 385,265 gallons. Gallons of hydrogen gas, right? Okay, calculate the density of the liquid hydrogen in units of pounds per gallon and grams per milliliter. Express your answer to 3 significant figures. What is the specific gravity of liquid hydrogen? Okay. Calculate the density of liquid hydrogen in units of pounds per gallon. So to do that, we just take our pounds and divide it by our gallons. That's 227,641 divided by 385,265. So I'm getting 0.591. They said 3 significant digits, so we rounded up that 0.5908 to 0.591. 0.591 pounds per gallon. That's the density of hydrogen gas in pounds per gallon. And now we're supposed to determine that what 0.591 pounds per gallon is in grams per milliliter. Alright, so this is a conversion problem. We want the answer in grams per milliliter, equal sign, what the units we want, and then we write over here the units we have. 0.591 pounds per gallon. Okay, so we have, we need to get pounds to grams, so we can go to our table 2.3. Mass, there's 1 pound, 453.6 grams. 1 pound, 453.6 grams. Pounds go on the bottom because we need to get rid of these pounds. And grams go on top because we want to be in grams, right? So, 0.591 pounds per gallon. If we multiply that by 453.6 grams, because that's how many grams there are per pound, then we'll be in, now our units will be in grams per gallon. Now we need to get gallons to milliliters. Again, table 2.3, gallons, there's 3.785 liters per gallon. 3.785. So if we have gallons on the bottom, for every 1 gallon, 3.785 liters, right? So now we're converted into liters. Our gallons, oh whoops, we did that the wrong way. We need gallons on the bottom because we need the gallons on the, we need gallons on the top here because we need gallons on the bottom to be crossed out. So we need liters down here. So 1 gallon, 3.785 liters. And then we want it ultimately in milliliters, so we need to convert that liters to milliliters. For every 1 liter, there's 1,000 milliliters, right? 0.5, because then we can just calculate it out. 0.591 times 453.6 divided by 1 divided by 3.785 divided by 1,000. All right, 0.591 times 453.6 divided by 3.785 divided by 1,000. Okay, so I'm getting 0.0708. Alright, and that's grams per milliliter. So that's the density of hydrogen gas in grams per milliliter. I'm going to double check that. 0.591, lots of numbers there, make sure I didn't make a mistake, times 453.6 divided by 3.785 divided by 1,000. Okay. Alright,
So we have the answers here: 0.0708 grams per milliliter, 0.591 pounds per gallon. We had one more question, right? What is the specific gravity of liquid hydrogen? All right? So for the specific gravity of liquid hydrogen, for the specific gravity of anything, it's the gravity, or it's the density of your compound in grams per milliliters divided by the density of water. And so under these conditions, let's see, does it give us a temperature? It doesn't give us a temperature. So we have to assume the density of water is 1 gram per milliliter. So that will be the specific density as well. And we can double check that, or the specific gravity, sorry, of liquid hydrogen. We can double check that one in the back of the book. Make sure we got all those answers, a lot of answers there.